Sorry, there was a little bit of delay. Hi, everybody. We're the Tap Shoe Friction group. It's me, Grace, and then I have Cora, Vinny, and Sophia behind me. You'll kind of get to see all of us. We're going to pass the camera for each of our slides. Our group is looking at tap shoe friction and the effects that different flooring materials have on our ability to tap dance. So a little bit of an overview of what we're going to talk about in our presentation. We're going to start with our problem background, and then we're going to go through our different testing plans and procedures, as well as our results and findings, and then we're going to do a little bit of analysis on our data and talk about potential next steps for a project like this. So some background: traditionally, dance studio stages use Marley flooring. This is a type of rubber vinyl material. It provides enough grips to dancers without risking dampening noise too much. It is important to note that Marley is used for all different types of dance, not just tap shoes. So it's oftentimes stages will have to use tap mics in order to pick up the tap sounds properly for performance purposes. So we just wanted to see if this flooring was truly the best option for tap dancing specifically, or if it's just the industry standard because it's the most versatile material. And I'm going to hand it over to Sophie. Oh, wait. One more slide. Sorry. What makes good flooring? So before we get over to our testing procedures, there are two key parameters when it comes to flooring materials. Grip, so that's how much friction your tap shoe makes with the floor. You want enough grip to make sure you don't fall when you're dancing, but you don't want too much friction to the point where it impedes your ability to perform tap steps that involve different parts of your foot sliding on the floor. And then we also looked at sound quality. So this is a mix of how loud the tap sounds are. So does your ear pick up on the sound properly? And how crisp the taps are. So if it's too loud or there's too much vibration, everything's going to sound the same. And in tap, you're using different parts of your feet and different parts of the tap shoe to create different sounds. And in theory, they should sound different. And part of that is due to the flooring. Here's Sophia.
So for our test procedures for friction, we used a piece of plywood as our base, and then we marked on the plywood where we want to put the flooring sample. We also attached a protractor to the plywood so that we could measure the angle at which we lifted up the plywood and when the shoe would slit. We then put the flooring samples on the marked area of the plywood, and then we set the tap shoe on top of that flooring sample. For the noise test, we then we marked 3 different heights above the plywood. For the friction test, we raised the plywood until the shoe ultimately slid. There were 2 different angles that we measured, one at which the tap shoe started to move but didn't fully fall off, and then the angle at which the shoe fully slid off the sample. We repeated the test 3 times for each material, or 5 times for each material, and then we calculated the average slip angle and average slide angle for each material, and then we use those averages to calculate the coefficient of friction for each material. So this is a picture of our setup. We also had a piece of wood on the floor, or tape on the floor, just to mark where the wood was, so if it ended up slipping forward, we could account for that. And then that yellow thing next to the piece of plywood is the protractor.
So for the test procedure for noise, a piece of plywood was marked where the floor sample would be placed, and a protractor was attached. The flooring samples were then placed on the marked area of the plywood, and 3 heights were marked with tape along the wall above the plywood. For the noise test, the shoe was dropped from 3 different heights: 5 inches, 10 inches, and 15 inches, and a dancer performed 2 different tap moves on the floor, 1 flat and 1 stomp. The decibel level of each drop/step was recorded. The drop was repeated 3 times for each height per material, and each tap step was also performed 3 times per material. The decibel levels were averaged at each drop height for each material. Here we have our setup for a regular noise test, as well as a human noise test where the dancer would stomp onto the surface.
These are our results for the friction test. The graph shows the average move and the average fail for each floor material. From the table, you can see that the Marley was the most consistent with the move and the failure, and was also not super low or super high for either factor. These are our noise results. So the first graph shows the results when the shoe was dropped. from the heights of 5, 10, and 15, and it shows the average drops for all the materials. And the second table shows the averages when the dance move was performed on the different flooring samples. From the findings, we can see that the carpet and tile were outliers. This was expected for carpet, not expected for tile. And Marley performed well, but it did not significantly outperform linoleum, hardwood, or plywood. One thing we also had to take into account was using decibels instead of hertz for our noise readings provided us with incomplete results because our ears perceived certain floorings as louder than the decibel reader reflected them because the frequency that the floor was impacted and the decibels were not the same. In conclusion, we can say that despite Marley not significantly outperforming other flooring, it did not perform poorly, so we would still recommend Marley as the ideal tap flooring. This reflects the industry standards and is conclusive with what we thought in the beginning of this experiment.
All right, just to finish it off with a couple of next steps. So if we had more time, we would have loved to explore some performance-based frequency noise testing. We actually ended up breaking our tile sample during our noise testing, so any further testing is not really doable with the materials that we had. Another reason why tile would not be an ideal flooring material, but frequency levels might provide us a more complete picture of the sound quality, as it's important to be able to hear the clarity of the noise as well as the loudness level of the noise. And then it'd also be interesting to explore different types of dance shoes on these flooring samples. So if you want a flooring material to be multi-purpose, which is what most dance studios and stages would want, you're going to want to explore this type of experiment with a bunch of different types of tap shoes. So again, thank you to everybody who helped us out with this project, specifically Dr. Hoover and all of the awesome 401 TAs.